Okay, so there seems to be some confusion about Newton's third law. So I kind of want to talk about it in relationship to the lab that you did. So they had a cart and we had blue people and we had red people. So let's say in this scenario that we have a force of 50 newtons to the right and 50 newtons to the left. So that means that my net force is 0. And if my net force is 0, if I have 0 force, then I would have 0 acceleration. So that means Newton's second law would apply to this situation. Newton's third law does not, because Newton's third law has to have two different objects. So let's say that one of my forces is, we'll say these are the red people. So I have the red people pulling on the cart. Okay, so this was a force at 50 newtons. That means the paired force that goes with this is the cart on the people. And those would be equal and opposite. So in that case, these would be my red people. If I were going to draw a force diagram of my red people, then I would have a 50 Newton force here. This would be the cart that's acting on the people. Okay, so in this case, we were looking, in our situations, we were always looking at the cart. Okay, we were looking at the forces that were acting on the cart. If I want to look at Newton's third law, I need two pictures. I need the force diagram for the cart, and then I need a separate force diagram of the people. Okay, so it's two different objects. I can't be talking about Newton's third law when I only have a picture of one object, because those forces, this one and this one, those are the two equal and opposite forces, and they're always going to be on two different diagrams. In the lab, in the comments, I talked a lot about having two objects, and I talked about, let's say, I can't draw very well, so we're going to pretend this is my nail, and then let's say over here, we'll say that's my hammer. Okay, so the picture of the nail, I would have a force here that's acting on the nail by the hammer. So I would have hammer on the nail. Then I would need to have a picture of the hammer where I showed the nail exerting a force back up on the hammer. So nail on hammer. I would have to have two separate pictures, one showing all the forces that acted on the nail, and a separate picture showing all the forces that were acting on the hammer. And those two companion forces, those two Newton's third law forces where they are equal and opposite, those are on separate pictures. So when we say F net is equal to 0, we're talking about one object and we're looking at the forces that are acting on that object. Okay? And an F net of 0 doesn't have anything to do with Newton's third law, because when we are adding up the forces, this is for one object, the object in question, in this case the cart. Okay? Newton's third law is two different pictures, and we don't find a net force of two different pictures. We're looking at one picture, and the net force is the sum of those forces. So I just want to try to make clear that Newton's third law, you have to have two separate bodies or two separate objects that you're looking at. And we never say that F net is 0 when we talk about Newton's third law, because F net is 0 is talking about one object. For Newton's third law, we have to have two separate objects.